Hello and welcome to this Automation Academy Mastering the Machine webinar for the 1st of March 2024. Today's topic was Alan Bradley, CODESYS, and object-oriented programming. And I had a guest appearance by Gary Pratt, showed up and talked a little bit about his object-oriented industrial programming concept, and I hope you enjoy it. Good morning, ladies and gentlemen, boys and girls, and welcome to this, the 71st Mastering the Machine webinar. And this one is on PLC philosophy. We'll be talking a lot about Alan Bradley, CODESYS, backoff, and object-oriented programming, which I touched on in the last webinar, which was number 70 I did on Automation Direct. I had just gotten my new Automation Direct CODESYS controller and had started programming some in that. And we'll be continuing some of that discussion today using some of the same topics, talking about some of the same people that are involved in this. And I'm hoping that some of them show up to this webinar, but so far nobody has showed up yet. But I like to get this stuff out of the way just for the recording purposes. So what is the Automation Academy? This is a membership website that I started several years ago, and I put a lot of my written documentation on it, and there are a lot of training videos for Alan Bradley, Siemens, Beckhoff, CODESYS to becoming, in particular, on the Alan Bradley or the, not the Alan Bradley, the Automation Direct platform, since that's what I have. Although, of course, you can run CODESYS just on your computer to simulate programs and things. There is some job and aptitude assistance on there based on Ken Coleman's material, some systems integration information, and that sort of thing. And I do have a library of training and technical documents, some of which I've written and some of which I've just collected over the years. We do have a community with some interest groups, IO Central. Not a lot of people attend that, but every once in a while somebody will show up there and we get some conversations going and things like that. And we do have these Mastering the Machine webinars about every 2 to 3 weeks. As I mentioned, this is the 71st episode over about 3 years. I do them every 2 to 3 weeks. Without any further ado, we will proceed on the subject matter. Oh, by the way, happy anniversary. It has been 4 years since my old office was destroyed by a tornado. That was March the 3rd, and today is March the 1st, so I figured I'd honor that with this episode. And what happened is I had a training facility March 3rd, and then it was destroyed by a tornado, and then 2 weeks later, COVID hit. So a lot of things changed, and that's kind of where I spun off to this much more online approach to things. I still do teach around the country and travel, and I rarely teach in my own facility anymore. I'm in an old house now rather than the old commercial facility that I have, but you can see here a little automate behind the scenes and things. Lots of fun information on that if you look at some of the old webinars. Anyway, today's topic, as I mentioned, is kind of PLC philosophy, some differences between different platforms. I noticed Gary Pratt showed up, and he's one of the people that I mentioned in here since he wrote a book called The Book of CODESYS, and I will be discussing that, and hopefully Gary will chime in on his version of object-oriented programming, which is object-oriented industrial programming. And he actually has a forum on that you can go and attend, and I'll hook you up with that address when we get to it. In any case, so the object-oriented programming, the definition, so several different definitions. I'm going to give you a short one here real quick first. I am writing a document on it, and it is mostly, a lot of this information is taken from other places. Obviously, I did not invent object-oriented programming, so I take other people's definitions. The Gartner definition of it is a style of programming characterized by the identification of classes of objects closely linked with the methods or functions with which they are associated. So this is a nice short definition. It's based abstract data types, UDTs or DUTs, lots of things in there. for storing data with the procedures needed to process that data. And it offers the potential to evolve programming to a higher level of abstraction. And then I grabbed a bunch of stuff from both the Beckhoff website, which has a good explanation of object-oriented programming, and also from Wikipedia. And a lot of this is from Wikipedia. It just defines what a class is and instances and inheritance, things like that. If you are a PLC programmer, you probably already know some of these terms. If you use function blocks, understanding what an instance of a function block is kind of important. So you would probably know that, and then instantiation of that instance. Lots of terms here. So what I do when I write these things up, I usually kind of make them bold, and I discuss a lot of the different things here, some of which will matter and some of which won't. And then I went through and I talked a little bit about PackML, and in this let's see, I have a bit on PackML. I'll skip the Beckhoff reference right now. But packaging machine language, it's kind of a technical standard. And I got involved with this about 20 some years ago, doing some work for Procter & Gamble. He used a lot of PackML and Wonderware. And they put a lot of these little diagrams right here actually on their touchscreens. And so part of their debugging process would be to go through these different blocks. And as you can see, they're not exactly objects, but they sort of look like objects, right? You are in one state. It's kind of a state machine, and you could be, for instance, stopped or stopping or aborting or that sort of thing. And then they also have some nice little hierarchies for designing your program, that sort of thing. And I grabbed a lot of this off of Wikipedia. Again, they generally have good resources for some of these definitions and things. But in any case, some of this has made its way, especially into machine control. And I'm going to differentiate in this webinar between machine control and process control. A lot of Gary's material was on process control, I noticed in the book of CODESYS, and I've kind of taken that to heart and trying to kind of turn it into something that relates a little more to machine control, which is much more of the industry that I'm involved in. Not so much packaging machinery, but large industrial systems that are normally done with things like Allen Bradley. So that is one of the topics that I mentioned here. Also, I do want to talk about Beckhoff a little bit. In particular, Jacob Sagatowski has written a whole lot of material on object-oriented programming. And his approach is quite different because he is from a true software background. So he leans a lot more heavily on the interfaces and methods and things like that than you would do in a simplified version of object-oriented programming, such as what Gary has mentioned with the object-oriented industrial programming. So he, for instance, strongly recommends not using any global variables of any kind, apparently even I/O and things like that. And that would be really confusing for, I think, people that were using standard PLCs, such as used in the United States. So the United States, and I kind of wrote this in my little write-up here on the other screen. So I'm going to kind of read this. The little intro that I wrote says, it's estimated that Allen Bradley owns well over half of the market share of PLCs in North America. Since the United States is currently the largest economy in the world, it's important to look at current PLC programming methodology using that platform. So what I did here is I actually used an Allen Bradley template, and I'm going to talk about a little bit about PLC programming templates and why you should use a template. It is basically an example program with a structure, guidelines, and comments built into it. It's a kind of a starting point for your programming, and it often includes blocks of pre-written code. And that doesn't necessarily mean objects, right? Blocks in that manner. As a matter of fact, Allen Bradley does not lend itself to true object-oriented programming. They don't even call their function blocks, and you can't edit them online, which is a little bit frustrating at times. They use something called add-on instructions, and it seems like they've made up a lot of their own terms for some of these things, like AOIs instead of function blocks. But instead of, well, anyway, along with a PLC or a software spec, it may be required by the customer that the programmer follows it. And that's kind of where I come in, because most of my last 30 years has been following those specifications for large companies. When I owned my machine building company, people would often give me their template and they would say, okay, we are Denso and we're much bigger than you, and you have to write your program according to our template. And at that time, I started out in the 90s, there really wasn't a object-oriented method of doing that with things like the old slick programmers. So they would just give you an example program and say, write it this way. And then I evolved into working for a very large custom machine builder here in Nashville. They were called Wright Industries at the time, and they had their own template. And sometimes customers would come in and say, you have to use our template. For instance, GM or 3M or some of those people would say, we have a well-established template. You need to write your code. It was Allen Bradley only, and you have to write it in that style. You must follow these instructions. If you don't, we're going to make you change it, or we're not going to pay you. So that obviously is an important feature here. So this is an example. I still do a lot of work with Allen Bradley, and this is an example of a very large Allen Bradley program. This is all of the devices, and it doesn't even show all of the devices here, but you can see each one of these represents a separate Ethernet address, right? All of these different things, and a lot of I/O cards and things like that. This had 14 robots, 21 large valve banks, 17 vision inspection, Cognex cameras, things like that, barcode scanners, servos, laser markers, over 2,000 discrete I/O, some analog I/O, but again, in machine control, you don't use as much analog. There certainly is analog in relation to robots and servos and things like that, but you really don't deal with those. You deal with them as separate controllers. In any case, this is a layout of the program itself, and these are not objects, right? Each one of these are separate programs. Each one of these things with this little arrow are separate programs, and they contain routines inside of them. What you see over here on the right is two of those programs opened up, and you can see it's pretty standardized. The routines are in alphabetical order, which is why they are numbered this way, and this is also the order in which they're called. There is an initialization routine, and then a kind of a stop general thing that stops all of the equipment, and then auto sequences, inputs, outputs, and this is a pretty standard way to do things in Allen Bradley. I've done tons of webinars using Allen Bradley, so I'm not going to emphasize any of those points, but this is a little bit of how they would lay out a program like this. In addition, there are true objects in here. These are all objects. Add-on instructions, which, as I mentioned, are what they call function blocks. You have some variables that you feed in. You can see an example of one here. This is AOI find sub message number. So it finds a message number within a larger message structure, and it just does what it does. You don't need to look inside of it, and it will tell you if it found a message of some kind, and then it will put it in a specific register. So completely different method of programming here. These UDTs, I just put some of them in here, but there are, I want to say, when I made this image, I think I had 7 pages of this listed, these UDTs, which, by the way, if you are doing CODESYS or back off, they call them DUTs. The concept's the same, right, as a structure of data types. Most of the code is written in ladder, and there's again, I'm not here to argue the merits of a specific language over another. As a matter of fact, I'm starting to become a big fan of this continuous function chart that Gary has mentioned, and hopefully he'll chime in on that. I really tend to like that language, but you need to pick the language that is appropriate. And in some cases, like I said, these big templates, they will tell you, we use ladder. And this is also proof that you can write an entire program in ladder And it's really not as difficult, and it's not as, if I had to write it in ladder in CODESYS, yes, I wouldn't want to do that because I don't have all these special instructions, right? Allen Bradley, one of the things they're good at is building special instructions for special purposes. This is file bit compare. It will look at an array and tell the difference between elements in the array. It's just part of a library. So if you already know all those instructions and everything, then you would use those. And then if you want to build your own instructions, there's an example of an AOI up here in the upper right. There is some structured text, but by and large, most of this is ladder logic. So another person that does CODESYS projects is a guy named Paul De Jong, and he is out of Canada. And interestingly, he teaches for automation training like I do. So he teaches Allen Bradley and Siemens when automation training contracts him to do that. They'll send him somewhere and we get to travel a little bit. But he also owns this company, Northern Dynamics. And one of the things he's doing right now is he's, I believe, down in the United States, converting an Allen Bradley program into CODESYS. To do that, right, I don't know if he's actually using this technique, but he mentioned this online on LinkedIn, and he just used a Rockwell example, and he said, you can make your CODESYS program look like your Allen Bradley program. And somebody obviously chimed in there, well, why would you want to do that? That sort of defeats the purpose of object-oriented programming. And I would agree with that. But at the same time, you do what the customer tells you. You can argue with them all you want to. You can say our platform's better, whatever. They're the ones who decided to move on from Allen Bradley, so they have reasons for doing that. I have lots of reasons for doing that, especially cost and software policies and lots of things. So I'm becoming a big fan of CODESYS. But at the same time, if somebody comes back and says, you need to use our techniques, they're paying me. And the only thing I can do is either turn the job down or come back and say, I could improve some of this a little bit or whatever. So he put this out there. I thought it was really interesting. Instead of, he just made folders for the tasks. And then for the programs, he used programs, which are a little different thing in CODESYS. And then for the routines, he used methods. He put methods inside of each of these routines, and he made it look like the layout of this program, right? Back, let's see, here, right? So if you open these up, you can see all these routines in here, and you can see all the separate programs and tasks and that sort of thing. So I thought that was interesting. All right, so finally on to CODESYS, which is where some of this object-oriented concept really kind of hits the point here using this platform. Gary Pratt, who's he's here. I can see him in the list of people here, and he has written this book, the Book of CODESYS. I don't know if you can see me here. Let me see. Not sure that I'm visible. Show grid video. There we go. So this is my copy of this book. It's an excellent book. Has lots of good information on it. This and a structured textbook that I have from Tom Major Antonsen are two of my go-tos when I get to this object-oriented stuff that's not ladder logic. And of course, for me, I've written a lot of books that touch on ladder logic and Allen Bradley, but moving into this new realm, I rely heavily on this book. And this kind of brought up the point of Gary's version of object-oriented programming, which is a little bit simplified over what, for instance, Jacob Sagatowski would be espousing on his Beckhoff. Jacob comes from a true software background, so he uses a whole lot of hiding things and interfaces and a lot of passing variables from block to block. And in my opinion, one of the problems with that is it gets very, very complicated very quickly. And if you are trying to maintain a program like that, you're going to be in trouble unless you do a whole lot of study and understanding. Now, maybe things are commented well, which would be, that would be awesome, but that still doesn't change the fact that somebody has to get into this thing very quickly and solve problems. That's the main task of a maintenance person. So sometimes people like to see things in a familiar manner, things that they're used to. By the way, this down here, this OOIP Foundation, I signed into this the other day. Gary has some of his blocks of code and things like that on there. And I think the intent there is to be able to share your code on that site. One of the things I found this actually on the CODESYS website, and this is also in Gary's book. And this is a kind of a graphical illustration of what Gary means by object-oriented industrial programming, right? You can build these blocks and you can actually graphically represent the control of a specific mixing tank. So here's a graphical version of it, and then here is a bunch of blocks that represent the different parts and things that would go with that. Now, again, I think this is very process control oriented. I would probably lay this out quite differently for machine control because, as I'm going to show you some of my blocks here, in machine control, a lot of the manual and auto functions are a really important part of the overall control of the machine. Whereas process control, I think each element can kind of stand on its own. You know, you have handoff auto and things like that, and you can put local stations into manual mode, and you really can't do that for a large machine like the one that I showed you with Allen Bradley. Everything depends on everything else, and the overall mode of the machine is going to be really important. But a lot of these concepts here where you have the valves, individual valves sticking off here, and you have inputs, this is used also in the Allen Bradley version of this. You would also have things, automation NTH calls, there's DI handlers where you have some timers associated with a lot of your inputs and things. I'm going to show you real quick one of the things that I've kind of adopted. This is a hybrid between some of the things that Gary is doing. For instance, he uses VI, which is a Visu input, and I use HI here, and that's because HMI is, we use a lot of HPB and HEND and H this and that to illustrate, you know, that this comes from the HMI or the SCADA system. So I've adopted this, but the rest of this, process output, process input, I think these are excellent definitions of how you might use object-oriented programming in this continuous function chart. By the way, this is a block of continuous function chart, and it runs all by itself. All I have is this parked on a page, and this handles all of my auto mode functionality right now in my CODESYS project. So this is just a kind of a look at Gary's approach to it. I think it's pretty cool here. This is, again, continuous function chart where you draw a line from an input into one side and output out of the other side. Well, actually, I think some of the inputs and outputs are on both sides here because these are outputs over here. But anyway, being able to look at this and diagnose what the system or machine is doing is a very important feature of object-oriented programming. The other thing that's an important feature is keeping a lot of these variables local to this block and not dealing with the complexity of what's inside of the block or a lot of the extra variables and things like that. So all that's really important in object-oriented programming. Again, Beckhoff is not exactly CODESYS, but it did come from CODESYS. Much of the coding is done the same. I've found that it's harder to export some of my work from a Beckhoff platform into CODESYS, so I'm having to type it back in again. It's probably just as quick to go ahead and type it. And again, because I come from much more of a ladder logic background, I've built some of my objects with a lot of ladder inside of them, which brings up the question, well, how important is the time that it takes to convert your ladder logic or your structured text or your function block diagram into machine code, right? And then convert the block here, right, into whatever that language is, ladder or whatever, and then that into machine code. So you're getting layer upon layer of information. Hopefully everything's happening in order. That's the important part. You do want to make sure that your inputs are processed first, then your sequences, and then your outputs. And that's all kind of handled in here. So we don't have to worry so much about that. and computers are much faster than they used to be, so I don't really see an issue necessarily there either. But a lot of this I will be testing on my local system here. I'll get to compare it with just writing standard code in Allen Bradley from writing a CODESYS program and putting it into my controller here. So anyway, those are some of my little objects here. Let's see what else we got. That's mostly the end of the actual slide presentations that I have here. I do have one other thing to show you here. I wrote a kind of a partial book on Beckhoff before I started my my little book here on CODESYS applications. And this is one of the things that you can do in Beckhoff. I'm sure you can do some form of this also in CODESYS. You can create a UML, Unified Modeling Language, block diagram of your program. This is an example of the UML for the class that I teach in Beckhoff. And this is just a little piece of it here, but you can see here there's some runtime stuff, and then I've got some toggles up here, cycle start, cycle stop. And it's kind of an interesting way to take all the code that you've written and turn it into a block diagram, sort of like CFC, right? Continuous function charts. So I found that very useful in Beckhoff to look at my overall program to kind of give a layout of it. But this is not representative of the language that it's written in. This is not continuous function chart. It's just a diagram representing all the different blocks, which are written in different languages. Some of them are in structured text. Some of them are in ladder. I did my sequences in sequential function chart. I tend to like that, even though it's kind of can get a little bit complex. I think I have some examples of some of those here. There's a little bit of ladder. There was a little block. Let's see, functions. I think I have some good sequential. There we go. There's a little example of a batching system with sequential function chart. Lots of kind of lesson things. And then I had people go through and build a little sequence here using these visualizations using SFC. So one of my goals in the Beckhoff class, and it will be the same when I do CODESYS classes for Automation NTH, is to have everybody program in every language, at least one application in each language. Of course, the people at Automation NTH are coming from an Allen Bradley background, so they're going to start out with ladder. They're quickly going to move into structured text, which is over here, and then they're going to probably move from there into a little bit of function block. You can float some objects out here like I've got here. You don't have to worry about attaching to a rail, and then moving into sequential function chart. So what I'm doing right now is turning a lot of this into CODESYS type objects rather than using Beckhoff. But a lot of my written material was based on Beckhoff, and I'm kind of changing my direction here and coming out with a training manual, a very small training manual compared to the book of CODESYS, but on CODESYS. And I'm going to be giving a lot of examples, and in particular about machine control, because that's mostly what companies like Automation NTH, JR Automation, ATS and ATC, which are large global machine manufacturers, custom machinery manufacturers here. So that's a lot of who my customers are. At that point, I'm kind of done with most of the presentation as far as this webinar is concerned. I do want to emphasize this again. There is a whole lot of other stuff that people need to be able to learn, not just PLC programming, right, but all these different things here. All these relate to each other: SCADA, HMIs, motor control, wiring, communication protocols, lots and lots of other things to learn. But on that note, I noticed Gary is here, and I'm hoping that Gary will chime in a little bit and explain anything that he wants to talk about related especially to either his book or object-oriented industrial programming. Gary, you there?
Yep. Frank, can you hear me?
Hey, I hear you.
Yeah, good. I'm on my morning death march with my wife, or otherwise known as our morning walk. So if I'm huffing and puffing a bit, That's the reason.
Well, at least you're in Florida, which is the weather's better than it is up here.
That's true. Yeah, it's beautiful here.
Yeah.
I just want to make a couple comments. First of all, the OOIP is not a separate technique. It's a subset of full object-oriented programming. So it's basically the, I don't know what percentage you want to use, but it's like 80% of the benefit and 20% of the complexity. So, like you said, that a technician is going to get lost or trying to maintain an full object-oriented program is going to be difficult. That's absolutely true. However, the subset that I've coined as object-oriented industrial programming, that subset is much more understandable, and I think the technicians are ready to make that step. And in fact, I think if you take somebody without any training at all, or somebody out of college, that they're going to understand the OOIP much better than they would understand traditional PLC programming. It's more intuitive. Everything we build is built out of blocks, out of objects, physical objects. Makes perfect sense for our programs, built out of objects as well. So that's and I just want to make one other comment. True, a lot of my examples are process control, but there are plenty of machine control in there too. There's a material handling plant that's all built with discrete controls, and the PAC-ML machine is in the training. I show you how to do the background off page things. If you look at the PAC-ML spec, they show you the very nice diagram, the state machine, and then down at the bottom there's this little asterisk that says, and you can reach, I forget what the terms are, aborted or stop, I think, from any block, but that's not in the diagram. And so how do you do that in a real, in your code? How would you do that without totally cluttering up your state machine, your SFC, if that's what you're using? So it shows you how to do that. So and I think we're going to have to agree to disagree on object-oriented programming or object-oriented industrial programming applicability to process control versus machine control. I think they're perfectly applicable to both. Your machines are built out of photoelectric eyes or motors or whatever. They're objects, and your program would be built out of those same kind of objects. So we might need to talk about that more offline to see what challenges you're finding in the machine side of things with that type of programming. Let's see. Yeah. We'll also have to agree to disagree on ladder as a good. What I call it is a block diagramming tool. When the tool that you use to make calls into other things. I think my opinion of ladder logic is it's a great language for what it was meant for: relays, timers, counters, things like that. Discrete Boolean logic, fantastic language. The problem is the tools didn't provide any alternatives. When controllers became more and more powerful, controller vendors didn't provide the languages that were appropriate for the new functionality. So, our only choice was to use ladder logic. So we use ladder logic basically as a block diagram building tool. And to me, I don't think it's well suited for that. I think CFC is a much, much better choice for that. Oh, and one other comment, sad news. The UML that we both like is being discontinued. I don't know the reason why, but it's going to be, it'll no longer be for sale. I think next month or the month after, it's being removed from the CODESYS store. And then sometime later, number of years later, it will not be usable at all. And you won't be able to open up your old UMLs in the new tools. I think maybe 2027 is when it's going to be totally removed.
Yeah, I think
as far as I know.
from my perspective, it was all just Beckhoff that I used that, and that's it was a nice tool to look at all the code that you'd already written. And I don't know that they'll get rid of it because they really are in control of their own platform now. I don't think it's as based on CODESYS anymore. But again, if it's not used in industry, then it might disappear. So this is an example again for those. I see a couple people have come in a little later. This program is written entirely in ladder, and it does not only do bit banging and material handling, it's doing a whole lot of pretty complex stuff. And the only reason that they chose this language, right, the primary language of ladder, is because Allen Bradley just is ladder. They have structured text. They have function block diagram. They do not have CFC. They have SFC, but also people often write their sequences just in ladder anyway, and it's pretty easy to diagnose, those systems, and so people know how to read that. I think that's the main reason that I'm kind of using that example here. And as I mentioned, it's somewhere somebody told me it's 60+% of the U.S. market right now, and so that's one of the reasons that people use it, is simply because it's here, and we're kind of stuck with some of the formats that the customers give us. You mentioned, for instance, the PAC-ML stuff, and other than Procter and Gamble, I haven't found it used very heavily, for instance, in automotive. I'm involved a lot in automotive and also in medical devices and pharmaceuticals. So those guys seem to be leaning. Again, there's some Beckhoff in there. I've got a call now to do some B&R training, which I have never done. I'm going to have to add that to my arsenal. I think it's got some similarities to CODESYS in that you can use all the languages and glue things together. I don't think they have CFC. I'm hoping everybody picks up CFC. I think it's a great platform. I think it's really nice to build these things out of building blocks like this. And it's kind of like, who cares what's inside of the block and what method you use to program it, as long as it works. The customer should never have to dig into those blocks anyway. So, I hope to see things, like this coming up in the future. Yeah.
Yep. That's the object of object-oriented programming, is the blocks stand alone. And
yep.
You don't have to mess with them. And, you don't have to do, alarm lists or persistence lists or all that other stuff that we used to have to do in the old days, or we'd write some macros when we would export our project out, write some macros to gather up all the variables that we've named a certain way so we could put them into an alarm list or what have you. Don't need to do any of that anymore. Everything's all built into the object. You just plop down the object, configure it, and run with it.
Yep.
And then the beauty of that is that now if you make a design out of these self-reliant standalone objects, that design itself can now become a self-reliant object in a bigger design.
Yep.
And your design can grow and grow and grow, and your complexity just stays fairly constant instead of growing exponentially like it does in traditional PLC programming, where everything depends on everything else.
Yep. Well, in this case, like the diagram I'm showing right now, these are all kind of separate timed tasks. And as I said, there's probably 100+ programs, separate programs in here. And each of those are very standardized. They can take any one of those and they're going to do the same thing. And again, if you open them up, yes, they have different routines, but they use the same routines over and over again. So these numbers where you see, home sequence, it's the same block, whatever you're homing, it doesn't really matter. And again, if you don't have to dig into the code inside of it, it sort of operates as a block, but you cannot do true object-oriented programming, certainly in Allen Bradley. And unfortunately, I say unfortunately because I truly believe that, I'm stuck with Allen Bradley. I so much of my work comes from it that the customer is telling me that's what you're going to use, at least in this country, at least probably until I'm gone. It's a very high percentage of what we have to do. But yeah.
So exactly what you're saying was very common 5 years ago. Every machine builder I talked to would say that, we'd love to do the hardware I was selling at the time that was based on CODESYS, but our customers demand Rockwell.
Hmm.
Now I'm only hearing that maybe 50% of the time now. So a lot of machine builders are saying, well, if they don't specify, we use CODESYS. The only time we'll go back and use Rockwell is if they demand it. We can't talk them out of it.
Sure.
I think things are changing rapidly.
They are.
That's
For instance, I know JR Automation has a very large backoff group right now that does backoff programming for automotive, and they accept it and everything.
yeah.
But there's a whole lot of legacy stuff in there. Automation NTH, which is the company that I do a lot of work for in medical devices, they've gone the backoff direction, but they've also done, I want to say, 10 internship trainers on different CODESYS platforms. I think it's coming. At the same time, I just haven't. I've seen some very large backoff programs. Jacob Sagatowski worked on some world-class, oceanic power systems and things like that. But I haven't seen a really large U.S.-based CODESYS program yet. I'm hoping somebody can show me one and give me an example of how that would be laid out and how you would build that. But I guess what I mean by large is in the, like the oil and gas pipelines or the large automotive lines or any of that stuff. I'd love to see that implemented and see what it looks like.
I can tell you a large, innovative online retailing company is switching over to CODESYS lock, stock, and barrel. And
Cool.
Also I know one U.S. auto manufacturer and one German auto manufacturer that are both switching over. So
Awesome.
it's happening. Yeah.
Yeah.
Especially the virtual control is what's very attractive. They can just run all their PLCs on a redundant servers next to the factory floor. And all the complexity of trying to deal with all these individual PLCs is gone. It's all in the servers.
That is true. I work with a big beverage manufacturer down in Miami, and they have everything from old GE to Siemens to Allen Bradley to they're getting into some computer-based systems. So far, the computer-based systems, they've used the Siemens platform, and it's not been very useful. It's not been very user-friendly as far as the compiled code and everything. So I'm hoping to move them a little more in the CODESYS direction. Yep.
Yeah, I think that's a great way to go.
Yep. Well, that's mostly it for me today. Gary, thanks for hanging out and stopping in. I hope your walk went well, and
yeah, I'm still breathing.
That's a good thing. I need to be getting out and doing a little more of that myself. I'm headed to LA on Sunday, and I'm going to get to maybe walk the beaches and things, and it'll be a little warmer. So I'm looking forward to that.
Sounds good. Have fun.
All right. Well, thanks a lot. And again, remind everybody of this last page. Yes, there's lots and lots of other stuff that you need to know, not just the PLC stuff, but of course, motion control and robotics and electronics and all this stuff. It's kind of the building blocks of industrial automation. And we will be holding some other webinars on different topics as time goes on. The next webinar, as far as I know right now, I have it scheduled for March 29th, but I may be able to do it a week early because I had a trip to Phoenix that was canceled, and I'm now going to be in town that week. So possibly the 22nd. And the topic will be the Automation Academy itself. I'll be doing a little guided tour, showing some of the different videos and features in there. And hopefully some of this, CODESYS and backoff material and some of the things that are evolving, as time goes on, we're getting a lot more into this object-oriented, these techniques, and hopefully we'll be creating more material on that. I am writing 2 new books, one on Automation Direct platforms, the click and productivity, which is mostly, again, back to the old ladder logic stuff, although it is tag-based. And the other one is a CODESYS training manual specific to the Automation Direct platform. And it's going to go through the exact same procedures that I go through when I teach the typical classes. for back off and things like that. I'm going to go through and have people build different blocks in the different languages. It'll probably be a 4-day class with some videos attached to it. And it will be available on the Automation Academy. And of course, you can get my books on Amazon and Barnes & Noble and that sort of thing, for those of you who are already familiar with that. But thanks a lot, everybody, for hanging out. And please subscribe to my channel on YouTube and check out the Automation Academy. Visit IO Central. This one's free. And check it out. And thanks for showing up.